Hi, are you also the one who is confused between those organic chemistry terms like aromatic, non aromatic, anti aromatic? Come, let me break down for you. So, aromaticity. Now, it follows Huckel's rule. Very basic. The compound should be cyclic, it should be planar, that all the carbon atoms in it should be sp2 hybridized. Okay, the system should be conjugated system. Now, what does that mean? It should either have single bond, double bond like that, or else it should follow like double bond, single bond, positive charge, or double bond, single bond, negative charge, or double bond, single bond, lone pair. This is the conjugated system. Now it should also follow 4n plus 2 pi electron routes, like for example benzene. Okay. Now this has this 1, 2, and 3. 3 pi bonds means 6 pi electrons. So if you put n is equal to 1, then 4 plus 2 is equal to 6. So benzene is an aromatic compound. Now if you go on further to the next example, you can see here there are 2 pi electrons. For example, if you put n is equal to 0, then 2 pi electron. Also, it is conjugated. For example, double bond, single bond, and positive charge. It is cyclic. Also, it is planar. All the carbon atoms are sp2 hybridized. Now, coming here to pyridine. Pyridine has 6 pi electrons. Now, you'll be saying that these electrons. So, basically, these electrons doesn't involve in conjugation. Okay, so we don't include it, and this is something which you have to remember. So 6 pi electrons, it has 3 pi bonds. 3 pi bonds has 6 pi electrons. It is also cyclic, it is also planar. Further to next example, furan. Here the 2 pi bonds, which means 4 pi electrons. Also this lone pair involves in conjugation. You have to remember this, that in furan, thiophene, and pyrrole, the one the lone pair which is present, it involves in conjugation. So this is how you can determine what is aromatic. Now, what is non-aromatic? For example, if I take a compound cyclohexane, this is non-aromatic because it is sp3 hybridized. First of all, it is cyclic, but it is not planar. So this rules out from the Huckel's rule. So we have these anti-aromatic and non-aromatic compounds as well. So now non-aromatic means the aromaticity means the compound should be planar, that is sp2 hybridized. Now in non-aromatic compounds you can see that the compound is cyclic, of course, but they are not sp2 hybridized. For example, in this cyclobutene, you can see these two carbons are not sp2 hybridized, they are sp3 hybridized. So basically this is non-aromatic. Here the same, this is sp3 hybridized, so it is non-aromatic as well. Now this compound, you can see that it has 8 pi electrons. Now you might think that it is anti-aromatic, but no, it is not anti-aromatic. Basically this compound doesn't lie in plane, so basically it is also non-planar in a sort of way. You have to remember this example. So this is non-aromatic. This as well, here you can see that this one is basically sp3 hybridized, so this is non-aromatic as well. Now anti-aromatic. Anti-aromatic means you have to see whether it has 4 pi electrons, 8 pi electrons, or 12 pi electrons. If that is the case, then the compound is anti-aromatic. For example, in this, here you can see that this is a negative charge, which means 2 pi electrons. Okay, now this is also 1 pi bond, means 1 pi bond means 2 pi electrons. So this is anti-aromatic. This is anti-aromatic as well. 1 negative charge, 1 pi bond, 4 pi electrons. This also 2 pi bonds, 4 pi electrons. So anti-aromatic. Aromatic here, for a clear understanding of yours, you can just see whether it has 2 pi electrons or 6 pi electrons or 10 pi electrons, 14 pi electrons. Then simply it is aromatic. For example, this, you have 2 negative charges and 1 double bond, which means this is aromatic. Remember, this is also aromatic because see, this is not sp3 hybridized, it is sp2 hybridized. You have a negative charge here. Now this you might see that this is not aromatic, but yes, it is aromatic because this double bond at last, this is out of plane. So this is like it exists as benzene, So this is aromatic. Now aromatic again further are divided into benzenoid and non-benzenoid. Benzenoid means it has some similar structure to benzene. For example, if you see naphthalene and anthracene, these two, naphthalene has two benzene rings and anthracene have three benzene rings. So it has benzene involved in its structure. So these are benzenoid. Toluene, the same case, benzene ring with one methane group. If you want, you can Google the thing structure. You'll get a clear idea. Then non-benzenoid. In this, you can see this troponium cation. This has six pi electrons. It is aromatic, but it doesn't look like benzene, so it is non-benzenoid. When we talk about stability of these compounds, remember aromatic is more stable, than comes non-aromatic, and then comes further anti-aromatic. Thank you so much.